Good morning, ladies and gentlemen. Welcome to this learner support. So basically, this is to help you answer the questions in the homework. So we'll start with this question right here on similarity and congruence. So whenever you see such questions, just know that you're dealing with a similarity and congruence question. So the question reads, in the diagram below, PT, which is this from here to here, that is 10 centimeters. QS, which is from here to there, is 6 centimeters, and RQ from there to there is 12 centimeters. TP is parallel to SQ, so these two lines are parallel. Find the value or the length of PQ, which is right here. Okay. So now, before you even start answering the question, you need to identify the triangles that are similar and the length or the size that are similar. So in this question, we see that this triangle, there is a big triangle here, which you can form like that. Okay, which is right there. And since the length from P to from Q to R is 12 centimeters, meaning that we don't know the length here. So we can say the length from P to Q is X. Okay. So meaning that if we were to pull out this big triangle, it would have, let me just increase the pen size here. So we are saying that since we've been told that RQ, which is from here to here, is 12 centimeters, meaning that the distance from here to there is 12 centimeters. Okay. And we don't know this length of the big triangle. So we can say from P here to Q, we don't know the length, and we can just put an X there. Okay. Now let me pull out this triangle right now. So if I were to pull it out, it would have something like this. Okay, so this is one triangle. Then there is also this small triangle right here, so which goes like this, like that, and like that. Okay, so this small triangle has this side and this side, which is 12 centimeters. So basically the length here is 12. So this is 12 centimeters. So this is 12 centimeters. And we can also pull it out so that we have this other triangle, the small triangle right here. Okay, now we have two triangles. Okay, and now we just need to identify the sides that are similar. So we see that this side, okay, that is 12. So this side, which is PR, from this corner to this corner for this one, and there is also T there. Then this one has sides from here to here, which is Q and R, no, QSR, QS and R. This side, which is this side, is 6 centimeters. And this side, which is this side, is 10 centimeters. Then down here, this side is 12 centimeters, as I have indicated. Then for this one, this side will be this length plus this length, so which is X plus 12 centimeters. Okay, now what we just need to do is find the value of X here. Okay, and how we're going to do that is by similarity and congruence. And we also know that this is also the value of X right here. So what we just do is similarity and congruence here. We just equate areas that are similar, or sides that are similar. So this side is similar to this side, so we'll just say PT is similar to QS. Let's pick another side that is similar. So we say this side, which we know the length of. Okay, so this side, which is PR is similar to QR right here, similar to QR. And we can now put in the values. So PT is 10, so we'll say 10 is similar to, so 10 is equal to QS is 6, and we'll say PR, which is this one here from there to there, is X plus 12. Let me use the green color for differentiating. So PR, which is just this length here, and this length is X plus 12, so that is X plus 12 is equal to QR, which is here, which is equal to 12. Okay, then from here we can just drag these here so that we see them properly. So we can just drag them here. Okay, hope you'll be able to see. Then here we'll just cross multiply, so it will be cross multiplying. Okay, so it will be this times 6, so it will be 6 times, we open brackets, we group this as 1, which is X plus 12 equal to, we put an equal to sign, then this times this, which is 10 times 12. Then we simplify, so we distribute 6 times X, that will be 6X. 6 times 12, that will be positive 72. Then this side, we're going to have 10 times 12, which is 120. Okay, so 6 times X, 6X. 6 times 12, 72. Then here, what we need to do is we need to transpose this on the other side, because we just want to have one side with X terms and other side with numbers. So here, for us to remain with X side, X part only here, we need to get this the other side by introducing the additive inverse, or in simple terms, we just make this cross the equal sign. Okay, when it crosses the equal sign, the sign changes there. So this will be equal to, that will be equal to, there is a 120 here, and when it crosses the equal sign, it becomes negative 72, and this side will remain with 6X. Then here we can simplify. What is 120 minus 72? That will give us 48. And this side we have 6X. Okay, now we just need to remain with an X part alone here. So we divide by 6, the number that is here throughout. So this will be over 6. So over 6, and here over 6. So this and that cancels, and we remain with X being equal to, what is 48 divided by 6? So that will give us 8. So meaning that the value of X is 8. We've managed to find the value of X. So meaning that here, from here to here, that is 8 centimeters, meaning that this length here is also 8 centimeters, because that is the value of X as well. Additionally, we can find the length of PR. So PR, remember PR is equal to this, which is X plus 12. So we know what our X is. Our X is 8. So we just say 8 plus 12. And this would give us 20 as our answer. So that is how you approach questions like this. So basically, firstly, you identify the two shapes that are similar in the given diagram. You can separate those shapes and you identify the lengths of each side. So this side has this side has this side, and this side from here to here it's 12, meaning that here we don't know the length, so we can put an X there. Then we can say X plus this is the total length from there to there. Then that will be our PR. Then we say this from here to here was 12, so this will be 12 as well. Then we just equate the parts that are similar. So this part, which is X plus 12, is similar to that, and 10 is similar to 6. Then we cross multiply and simplify everything. Now, from here, let's just look at how we can find the square root of a number without using a calculator. All right, so we have this question: evaluate the following. We have root of 7. So I previously gave you a formula to say root of a number, say that number is D. This can be split into 2. So we look for a perfect root closest to D, okay, which we're going to call A, okay? And we should find a number B such that when we add or subtract to A, it will give us D, okay? And if we have this, then the formula becomes the root of A, which is this number here. If we are adding here, then here we're also adding. If we're subtracting, here we're also subtracting. Then we write the B on top here over 2 is always part of the formula. So 2 times the root of A. So the root of A. So what is here is here. Okay. So now in this case, we have 7. So we'll start with root of 7. Okay. What is the closest root to 7, especially after 7? Okay. The number after 7 that has a perfect root. So the number after 7 that has a perfect root is 9. Okay. Now, for us to get 7, what should we add or subtract from 9? For us to get 7, what should we add or subtract from 9? If we subtract 2 from 9, we're going to get 7. So meaning that our A, according to the formula, our A is equal to 9 and our B is equal to 2. Okay, which is, we can just plug into the formula now. So this becomes equal to, so the root of the first number here, okay, since there is a minus here, we are going to have a minus here. If there was a plus here, we would have a plus there. Then we're going to have, this is our B, is representing B, so that is 2. We get the number that is there. Then divide by 2 times, always it's 2. There's always a 2 here. So this 2 is part of the formula. So let me just cover it in red. So this 2 is part of the formula times this 2, which is this 2 here, times the root of A. So the root of this, so which is just the same thing as the root of 9. So we bring this back here, which is root of 9. Okay. Then here what we do is just simplify. So we can write this as, what is the root of 9? So the root of 9 will give us 3 minus, here we have 2 on top there, divide by, there is this 2 here, times, what is the root of 9, which is 3. Okay, you can simplify this. You can simplify this. You see that the 2 there can cancel with that 2. Or you could just say this is the same thing as 3 minus 2 divided by 6. Okay, which simplifies to 1 over 3 anyway. So you can take 6 into that. So this would give you 3 minus 0.3333 and repeating. Okay, so when you punch in that, you're going to get, when you simplify that by subtraction, you're going to have 2.66667 and repeating. Okay, so you just leave it like that. So that is basically the root of 7. So the root of 7 is approximately 2.66667. So the 6 are many. Okay, and you're done. Okay, so let's look at another. Let's say the root of 3. Okay, so in this case we find the number that is a perfect root to close to 3, especially after 3, so that is 4. So what number can we add or subtract to 4 to give us 3? So we can say minus 1. 4 minus 1 will give us 3. Then in this case we're going to have square root of 4. So this is square root of 4. Okay, so if we're to follow the formula, let's write the formula here. So if we're to follow the formula is saying if you have a plus or minus b, this is equal to the root of a. If you have a plus or a minus, then b over 2 is always part of the formula. So 2 times root of a. Okay, so in this case, our a is the number that we know the root of, which is 4, and b is the other number. B in this case is 1. So we just replace in the formula there, and we get root of a, which is 4, plus. So here there is a minus here, so meaning that here there will be a minus. If there was a plus here, there would be a plus as well. So here it will be minus b, which is 1. So b is 1, so we put 1 there, all over 2 is part of the formula, so we put 2 here, times root of a. So root of a is just root of 4. Okay, so there we simplify. What is the root of 4? That is 2 minus, here we have 1 over 2 times, what is the root of, so the 2, let me put it in red because it's part of the formula so that you don't confuse it. So there's a 2 here times, what is the root of 4? That is also 2. So when this is simplified, we're going to have 1 minus 1 over, 2 minus 1 over 4, which you can divide and it will give you 0.222. Then you subtract from there, then that will be your answer. Okay, so you can finish this one up. Let's do one more question, then we can close this. All right, so just this last question. So if x is equals to 12, y is equals to 4, find the values of x squared, y, and 2x plus 4y. So these are some common questions you find in past papers, including the previous one that we've looked at. So but here, this is a simple question. You will just be substituting. So x is 12. So for the first one, we are looking for the value of x squared times y. You have to pay attention to which term is squared here and so on and so forth. Then our x is 12 and our y is 4. So where there is x in this question, we put 12. So this would be 12 squared times y, which is 4. We simplify that. 12 squared, that's 144, times 4. Then 144 times 4, this will give us 576. Okay, that is the first question. You've answered the first question. Then the second question, we have 2x plus 4y. We have 2 here where there is x. We are putting the value of x, which is 12, plus 4y, where there is y, we're putting 4. So we can simply say this is 2 times 12, which is 24. Then 4 times 4, that will give us 16. Then we can add this to give us 40. And we have worked out the other question here. So these are very simple questions. So for the other questions, I'll leave you to research. So, but these are the questions that I just thought you would need to just look at. Even as you are working them out, you have an idea of what you're doing. All right, have a great day. You're supposed to submit the work on Monday. So have a great day.